Hi Science Nines. This week we're learning all about Ohm's law. So grab a pencil and a piece of paper and follow along as we go through a few examples and learn how to use Ohm's law. There are three properties of an electrical current that we can measure and examine. Those are the voltage, the current, and the resistance. And all three of these properties are related to each other. So really quickly, remember that the voltage is essentially how much electrical energy the current has. The current is how many electrons are flowing. You can think of it like water, how many water molecules are flowing, or how many electrons are flowing. And resistance, how easily the electrons are able to flow. So again, you can think of it like water. So voltage, the amount of energy, would be like how much energy the water has flowing through a river, maybe how steep the river is. The current would be like how many water molecules are flowing, and the resistance would be something like if there are any rocks or maybe plants slowing down the flow of electrons. So when we're talking about electricity, the voltage, the current, and the resistance are all related to each other. And by that, I mean we can measure the values, and there's a mathematical relationship between them. And we can use that to figure out one of the values if it's missing. So for example, if I know the voltage and the current, I can find the resistance. Vice versa, if I know the current and the resistance, I can find the voltage. Basically, as long as I know the value of two of these, I can use Ohm's law to find the missing value. So the relationship is that the voltage of a circuit is equal to the current multiplied by the resistance. So if I'm trying to find the number of volts a current has, all I have to do is take the current and multiply it by the resistance. So when I'm representing this in science, when we use equations, it's kind of clumsy to write out these words. So what we do is we use something called variables to represent them. So voltage is represented by the letter V. Current is represented by the letter I. And resistance is represented by the letter R. So if I'm writing out Ohm's law using the variables, it looks like V equals I times R. And remember in math, when we write two variables right next to each other, it means that we're multiplying. So we could go ahead and put a little times sign in between if we wanted to, but it's quicker just to write them next to each other. So this means if you know the current, I, and you know the resistance, R, and you multiply them together, you will get the value of the voltage. But remember, we can use this formula if we have two other variables. So let's say, for example, I have the voltage and I have the resistance, and I want to find the current. Well, I'm not going to get into the details of how you would rearrange this, but using your math skills that you should have, basically the R, the resistance, would move over to the left side by dividing. So what ends up happening is we end up with the current equal to the voltage divided by the resistance. So I, current, equals V, voltage, divided by, which is what the fraction bar means, R, resistance. And there's one other version of the formula that we can use. If we're trying to find resistance, I would rearrange my formula again. So resistance is equal to voltage divided by current. And then remember, I'm just going to make a little legend over here, V equals voltage. And we measure voltage in a unit called volts. That's easy to remember. I is current. We measure current in a unit called amps, which we shorten to capital A. And R is resistance, which we measure in ohms. And the symbol for ohms is the Greek letter omega, which also is the Lululemon symbol. So there is Ohm's law. Usually when you see Ohm's law, it will be in this form here, V equals IR. But we can rearrange it to find current or resistance, depending on what the question is asking. So let's go through a couple examples. So let's look at this first example, number 1. What is the voltage of a light bulb that has a resistance of 4 ohms and runs on 2 amps of current? So there are a few steps that I require all of my students to show, whether you're one of my Science 8s, my Science 9s, my Science 10s, even my Physics 20s, or my Science 30s. So all the way to grade 12, I expect them to show this same work. The first step is always we list our variables. And I'll make a list over here. Let's list our variables. So we know voltage is what we're looking for. It says, what is the voltage? So that means our voltage is going to be unknown. So I'm just going to put a question mark in to hold its place. What is the voltage of a light bulb that has a resistance of 4 ohms? So my R is 4 ohms and runs on 2 amps of current. So my current is 2 amps. So I, remember, is the symbol for current, is 2 amps. So no matter what you're doing, make sure you list your variables first, because there are actually more formulas than just this one that you might need to use. So if you list out your variables, you can figure out which formula will fit the question the best. So you have voltage, resistance, and current. You know you're going to use Ohm's law. But remember, we have a few versions of it. Bear with me for 1 second. Remember, we had these 3 versions of Ohm's law to use. How do we know which one we need to use? Well, what are we trying to find? We're trying to find voltage. So I'm going to use the version of Ohm's law where voltage is on its own so that I can find its value. So that tells me that in this example, I am going to use V equals IR. And that is always our second step. Our second step is to write down our formula. And we write it down so that we can be extra sure that we're putting our numbers in the right spot, which brings us to step 3. Plug in your values. So all I mean by that is where I have I, I'm going to plug in the value for I, 2 amps. And where I have R, I'm going to plug in the value for R, 4 ohms. So I have the voltage equals 2 amps times 4 ohms. So that tells me that my value is 8 amps. So step 3 is to plug in your values. Step 4 is to get your correct answer with the proper units. If you don't put in units, so for example, if I said the voltage was equal to 8, I have no idea what I'm talking about. 8 what? 8 hugs, 8 kittens, 8 cookies, 8 push-ups. No, it's 8 amps. So make sure you always put your units in at the end. And this is all you have to do to get full marks. Show your variables, write out your formula, plug in your values, and then get me an answer with the proper units. Let's look at number 2 here. What is the voltage of a 20 ohm heater that uses 5 amps of current? So this one is also looking for voltage, so it would be very similar to the question above. So I'm going to just skip ahead to find one that is looking for a different value. Let's look at number 4. Number 4 says, what is the current that runs through a 50-volt electric stove, which produces 2 ohms of resistance? So the first thing I'm going to do is list out my variables. What is the current? So that means that current is the thing we're looking for. A 50-volt electric stove, I know, is my voltage. And 2 ohms of resistance is R. Sorry, my ohm symbol is messy. This time, I need to use the version of Ohm's law that has current by itself, I on its own. So I equals V divided by R. There's my formula. Now I can plug in my values. Current equals V, which is 50 volts, divided by R, which is 2 ohms. My final answer, current, is 25, and don't forget your units, amps. And that's it. That's the basics of how you use Ohm's law. Please make sure you go through and do the 5 practice problems on the Google Slides document. If you have any questions, please send me an email. I'm really happy to walk you through some questions on your own if you need a little bit of extra help. There is nothing wrong with that. Thanks, guys. Have a great day.